Well, there you go. So you've been listening to us endless chat over the last 20 minutes. Those of you who had too much time on your hands, but thank you for joining us in another one of our EPRA forums. This one I'm quite looking forward to. This is about common mistakes, or mistake proofing, if you like. The term Poka yoke is something I've used for many years, and it's Japanese for mistake proofing. And we're going to sort of discuss with our illustrious panel here how we can, common mistakes that are made, and maybe some hints and tips about avoiding those. Okay, so thank you. So if we go straight into it, please. So my name's Martin Robinson. I sort of introduce the forums for my sins. I specialise in the designing of electrical maintenance safety systems. So that's really my background and why they let me play in these things. Next, I'd like to introduce Alan Renstra. So Alan, if you'd like to tell us a bit about yourself, please, mate.
Sure. Good morning, everybody. Thanks for having me on for another forum, Martin. Alan Renstra. I'm the Director of Business Development with SDT Ultrasound, and we do consider ourselves to be the world's favorite ultrasound company. I won't go into the why and the how, but I do like being considered the world's favorite because it means it's a standard that we have to measure up to every day. Rather talk about why when I was first invited to come on to be a resource practitioner for EPRA, why it was first an honor for me to be asked by Alan Ross and yourself to join in, and it's also been a challenge. And sometimes I ask myself why. And I was reading Alan Ross, and Alan Ross is our leader here at EPRA.
Present, yeah.
And, yeah, he's also the editor-in-chief of Transformer Technology magazine. So I was reading his editor's letter the other day, and the latest issue, and he wrote how it's better to give than to receive, but then he said, no, it's actually better to give and to receive, or to give and take. And I really like that message because it resonated with me about why I want to be part of this, part of a contributing voice in EPRA. And it's not just because I come on here and talk about my passion and my expertise, which is around ultrasound testing, but it's also because I get to learn from people who, I look up to most people, because sometimes maybe I underscore my own technical abilities, but I've learned so much just from being associated with it. So I'll shout out to Alan Ross for giving me that reminder about why I'm here. It's not just to give my knowledge, but more to take. Well, Pirates Code.
No. And what you say is important. I mean, I'm glad you brought up. I mean, I know this isn't about the resource practitioner standpoint in EPRA. It was all about, look, this isn't come and be sold to, it's come and learn. And one of the things that we discussed, and you were in the original meetings, was, look, to be a resource practitioner within EPRA, it's about sharing your expertise and passion. And one of the things that we sort of broached upon, that we as resource practitioners have probably spent time in more different plants than the clients that we work with. So we have such a broad experience, and it's an ideal forum for us to be able to share that experience across, and every one of the guys on this platform here has worked across multiple industries. So, we wanted to give the resource practitioners the ability to share such a great font of knowledge. But yeah, no, we'll get into that a bit more. Thanks, Alan. Next, I'd like to introduce Roy Huff. I've known Roy for many years for my sins. Roy, if you'd like to tell us about yourself.
Yeah, good morning or good day, depending on where you guys are in the country, in the world. So thanks for the invitation. Alan, I thought that was a really good message. That's really well stated. So
absolutely.
Yeah, it was interesting in doing that, and it truly is that even from this event today, the panelists here will take from each other and learn from each other, and that's something that you always have to be open to. So the association that we have with EPRA has been one. It's kind of a natural fit. Alan Ross and I we have many stories to share, but some are rather amusing, at least to me. I still laugh and smile about them, but it was a good fit in that all of the technologies we'll talk about today are primary technologies for this high voltage. And as Martin was suggesting, we have seen so many different types of manufacturing and production and even commercial, et cetera, buildings and facilities that, but one thing they share in common is the high voltage, which is really the theme of this organization. So we've enjoyed being a part of it. And as a company, we are an infrared company and electric motor testing. Those are our primary technologies. And from that, we support that with training and service and some consulting as well. So I look forward to today.
And mate, I mean, Snell Group's been around a long time. I mean, I think it's important that people recognise that, you know, from when John started the company, it's one of the probably oldest quasi-independent companies in the infrared industry.
Yeah, 35 years.
Yeah, so that's to be congratulated on. Well done, well done. Next, I'd like to introduce Marco Tosi. Marco's joining us from Italy. Hopefully it's a little bit warmer over there than most of the United States, Marco.
Yeah, it is. So thank you very much. Thank you, Martin. And I would like to say thank you for inviting me again. This is the second time. It is always a pleasure. So thanks to you, to Alan Ross, to all the people in the background. I'm responsible for product management in Camlin Power. Camlin Power is a medium-sized company based in Northern Ireland. We provide monitoring systems for assets, but we also provide services and digital services, diagnostic services. Diagnostics on assets, this is our main core business. And I would like to say that in the past 1 year, actually 2 years, since we started to cooperate more with the Transformer Technologies magazine and with the EPRA, it was a really nice experience and helped a lot also internally in our company to find in a better way our identity and to understand what kind of education we can provide to the market, and what was a really nice experience, and we are so glad to be part of this family.
Excellent, thank you, Marco. And we're glad you're part of the family. And last but not least, I'd like to introduce Bob Razor. Bob, if you'd like to and again, super experienced guy, Bob.
Thanks, Martin. Yeah, I'm happy to be here, and SD Myers is a electric power reliability company that takes hopefully our knowledge and our association with, say, IEEE and many of the companies represented here to accent your reliability in transformers, switchgear, your electric power system. And I've been with the company a while. I'm a mechanical engineer that was happy to join the electrical industry, and transformers are our passion, as well as switchgear and the services for infrared and ultrasound and so forth. And diagnostics is a big part of what we like to do, to help customers interpret what we see, and then help you along the way to get everything in good shape and keep it there. So again, thank you for inviting.
It's frightening. I was just trying to add up the amount of years on the panel, and I stopped at 150. Yeah, that's I'm turning into my dad. I think it's terrible, but there you go. So we're going to jump into the forum now, but before we start, we'd like to start with a couple of poll questions. So here's the first question: in which of the following condition-based technologies have you received any type of formal training, or do you hold a certification in? Now, you can tick as many of these as you want, so I'll give you a couple of minutes just to answer this question. So again, it's a multiple question. You can put as many as you've done. It's just help us as we go into the forum to sort of understand the background of the attendees. Okay, so we should be able to get the results on that quite quickly now. So infrared and oil analysis, funny enough. Oil analysis #1, thermal imaging, ultrasound. Partial discharge doesn't surprise me, especially North America. If you're in Europe, we see partial discharge being used much more extensively in Europe than in North America. And power quality is something, again, we've had some great forums on. So interesting results, guys, interesting results. So we'll jump into the questions. So first question is to Alan. So Alan, at EPRA we talk about better practices. As a member of the EPRA certification working group, from your experience, what are the common areas that are misunderstood or get overlooked by inspectors using ultrasound to detect partial discharge in electrical assets?
Well, with the 5 minutes that I've got to answer that, I'll touch on just I made a couple of notes on the two big ones. But there's lots. We see lots of mistakes. And the first one is not respecting the asset and not working safely. So so in all of the training courses that we deliver, we're always it doesn't matter what element of ultrasound, whether it's to do with electrical assets or pumps or motors or leaks or whatever, we always hit on safety first. But when it comes to electrical assets specifically, we're looking at, we have two classifications of defects that we're looking for, and we simply refer to them as either binary defects. So binary defect would be something that you go out and you find it and you fix it. That's not usually possible with electrical assets, but to fix it on the spot, but at least to go out and identify it, find it, and say, okay, that has to be, that has to be scheduled for a closer look at. The second classification of defects are the ones that we trend and analyze. So we still go out and we inspect and we find, but then we don't necessarily say it needs to be fixed today, but we're going to watch it. We're going to watch it closely over the next few days or next few weeks and watch how it evolves. So either binary or trend and analyze. And then when it comes to inspecting an electrical asset, we're either doing it as an airborne inspection. So the defect is traveling from the source to our sensor through the air, or the defect could be structure borne. It could be inside of the transformer. It could be inside behind an electrical panel, in which case we have to use a structure borne or a contact method. And it's the types of measurements that we do in these two circumstances where I see a lot of mistakes, and it's mostly just misunderstanding. So for an airborne defect, say corona discharge that's traveling to us from a transformer, from a connection somewhere to our sensor, if we want to measure the amplitude or how severe that corona discharge is, we can't ignore the inverse distance law. And so the inverse distance law just says, okay, if I'm going to measure it from 10 meters or 10 yards or 50 feet today, and I'm going to come back and measure it next week, I need to be at the same distance because there's an attenuation of signal. So the inverse distance law is the biggest mistake that inspectors make when they're doing airborne inspections. For contact inspections, the biggest mistake I see is people ignoring what we call the acoustic impedance. And acoustic impedance is basically the equivalent of electrical impedance. And it just states that an ultrasound signal traveling through a solid medium, whether it be steel or copper or what have you, it's traveling through a medium. I like to say that ultrasound's introverted. It doesn't like to go out and hang out with other sounds. So it wants to stay where it's created. And so if it's traveling from one medium to another, there's this behavior that happens when it changes boundaries. And the best example I could think of is if you're putting a contact sensor onto a casing that's maybe sealed with a paper gasket. So now you're asking ultrasound to travel through steel, through paper, through more steel, and then into your sensor. And there's a certain amount of impedance that happens as it changes through all those boundaries that can impact our measurements. So if we ignore that, then we also set ourselves up for mistakes in our trending. And so those are the two biggest mistakes.
Excellent. And what would you say, easy ways of combating that, or a technique to combat those?
So for the inverse distance law, we like to just put an X on the floor. And so if
we just put a mark.
Yep, put a mark on the floor. We can log it in our software if we're taking a measurement and logging it, then we can log the distance in our software as well. But it's also important for an airborne inspection. So if I want to shoot at a bushing or something, that I want to check it from this angle and then go and check it from the other angle. So if I'm going to check it from this side of it, from 10 meters away, then I'll go to the opposite side and be also 10 meters away. But it's basically X marks the spot. And then as for acoustic impedance, again, the same thing. You can put an X on it. You can set up different ways of identifying where the optimal measurement point is to place. So you're always placing your sensor in the same place every time.
Excellent. So that, I mean, that bit, so a good mistake proofing technique for that would be, like you say, to have like little stickers where you make your measurements, or, you know, marking the inspection points and then logging those inspection points to the readings.
Yeah. The only thing about stickers is we make donut stickers so that we're not putting our sensor on the sticker.
Yeah, or paint. I mean, I've actually used like little tape, like what we do for thermography. We use tape for emissivity, but we use tape, little, you know, like the shape targets. But again, it's a nice, simple method to do that, and it will work very well, I think. No, excellent. Thanks, Adam. So we'll jump into the next question. So the next question's for Roy. So Roy, lots of mistakes are made every day by inadequate training of inexperienced technicians. Isn't that the truth? Yeah. The correct level of technician training has always been an area that has been misunderstood by companies using CBM technologies. With more low-cost cameras and not just cameras, low-cost test equipment really coming on the market, what are your training recommendations for keeping inspectors' skills at an acceptable acceptable level and adjusted to technology changes?
Good. That's a good question, and it's one we're facing. And maybe I can best relate it to infrared, but you're absolutely right. Costs are coming down across the board, and in some cases, capabilities are coming down with them. In other cases, they're staying the same, or we're getting better. So that's a tough call. But we do have a lot of infrared cameras out there now that are less than $1,000, and that's resulted in literally thousands of additional cameras being out there in the hands of companies or individuals using them. In the past, they may not have had the opportunity or the budget to acquire them, and this has created some interesting challenges from several perspectives. Many of these low-cost cameras have very acceptable specifications for some applications, but many of them have a situation that do not have acceptable performance specifications, and especially in the world of high voltage, as we would be talking about in EPRA. One of the biggest issues that I would see and misunderstood, and certainly creating some significant errors, would be a misunderstanding of what we would call spatial and measurement resolution. And by those phrases, I don't want to get into a training class, but ultimately just simply said, spatial resolution might be the smallest object I could see or detect at a given distance with a given camera lens combination. Measurement resolution is a different value, and same idea. It's what's the smallest object I can measure the temperature of at a given distance with a given camera lens combination. Understanding this, because again, if we're looking at small connections in a substation with a fairly low resolution camera, we may not see them. We may not be able to see them based on again, the resolution and the pixel size. And quite honestly, we certainly can't measure them, again, with some of these lower resolution, lower cost cameras. So from our perspective, one of our jobs is to make sure, and it's always funny to state it this way, but we make sure that our students and even in presentations like this, that people understand the limitations of the technology, but also of the equipment. So we deal with this emissivity word and with regards to the technology and a whole lot of other things, but understanding the equipment specifications is huge. So are there opportunities for these lower price cameras? Absolutely. Can be used for requalification of repairs, potentially mounted for continuous monitoring. They can obviously support lower voltage opportunities where our inspection distances can be closer. But we need to understand areas with where we can't use these because of their lower resolution or their limited optics. Another area that's worth just real quickly discussing is with regards to qualification and/or certification. There are several standards in place out there, AS&T, ISO, NAS. But when these standards were basically developed or established, it was back in the days when these infrared cameras cost $50,000.
Yeah.
Or more.
Yeah. Tell me about it.
Yeah, yeah, absolutely. And so in that case, what we saw was the need, a camera might only be in the hands of large corporations or large consulting companies or the government. And in these cases, we taught our thermographers to be multifaceted. We wanted them to be able to do everything with these cameras. Every application, buildings, mechanical, electrical, roof inspections, processing, whatever it was. And it made sense because we didn't have dozens of these cameras available to us. But because of some of these changes in the lower cost situation, there's a reluctance to send someone to training for 32 hours or 40 hours of training because the camera only costs $500. So why would I invest in that cost or of training? So there's been some disconnect there where, again, the concept is, well, I got an image and I'm ready to go to work. I don't need that training. But what we're looking at maybe as a possibility is that we would see a situation where individuals utilizing this, we might suggest they need application or trade specific training and or standards where we might be able to reduce the class length to 24 or 48 hours, to 8 or 16 hours and teach a specific application. And because the individual might not go beyond his trade or go beyond his specific application. So we're adjusting that by offering, we're not a full Monty class, so to speak. That's still available, obviously, but some specialty courses that would allow the individuals to better utilize the equipment for what they do day to day. So we're seeing some opportunity for application and trade specific standards as well.
But I don't think the clients do enough to demand pre-qualification. I mean, the amount of time I've gone out on sites where they just buy a camera and throw it at someone and say, it's only a camera, go and have a look, and they come back and they've got all sorts of I mean, it's not just infrared, that's multiple technologies, but more so with, I think, infrared and ultrasound, because people look at them as an extension of your sight or sound. So what's so difficult, So we, and it is. I always reflect back on a guy that I went on his site and had a phenomenal program, fantastic program. He was saying, well, we don't need windows. I can see everything I need to see. And I went, well, what do you mean? He goes, well, I've been looking through these windows for years and I haven't seen a problem. I went, well, because, infrared can't see through plexiglass. But I didn't want to make the guy feel silly. He just wasn't trained. So he was uninformed. He did the best with what he had. And I think it's remiss of us as managers to not say, look, training is super important, because the equipment's so low cost now and training's getting easier to do as well. I mean, I think COVID's pushed everybody in the online level, which again, it's a thing. But yeah, no, we'll speak some more during the town hall bit, mate. Excellent. Thanks.
It's oftentimes we don't know what we don't know. And,
absolutely. Isn't that the truth? Isn't that the truth? So next question is from Marco. So Marco, from your experience in online PD monitoring, where do you see the main benefits of using acoustic sensors?
Okay, so I have a wee slide here for helping me in this answer.
Excellent.
There we go. So this is a real case. I guess this is the best way to answer, showing something in the real field. So in this is a 63 MVA distribution transformer in Europe, and this transformer was fairly new, only 2 years of life, and it was already gassing. When I say gassing, I mean in this case it was primarily showing some hundreds of ppm of hydrogen and just a little bit of acetylene. And the OEM answer in this case was, no worries, is a stray gassing. So, which is quite a common answer sometimes. And basically the answer is just wait, it will settle down. But if there is just a little bit of acetylene, it can't be stray gassing. So what we did here, we installed online permanent monitoring partial discharge systems, okay? This partial discharge monitoring system was installed by using electrical type sensors, which means basically connected, as you can see in the slide, at the test tap of the bushing. Okay, this is a quite reliable way to detect both the 50 or 60 hertz signals and the partial discharges and correlate them, and also do some, let's say, intensity evaluation with volts or peak or nanocoulomb in the field. The PD monitoring system was able in this case to show that actually there was a partial discharge. Okay, there was a partial discharge, and you can see here the partial discharge phase resolved pattern showing the activity. And in this easy representation, this is a ternary plot that is inspired by Duval triangle. We use this for partial discharges. It shows basically in which phase the partial discharge is located. Okay. Of course, with those sensors, you can't do any triangulation. You can do any accurate location, but at least you can say which winding, which phase, okay? And this is extremely helpful because after that, we went in the field with acoustic sensors. And it was just off-the-shelf acoustic sensors. It was not a specific, let's say, system made by vendors, and we used just an oscilloscope. And in less than 2 hours, we were able to locate the source of the partial discharges and the very top of the column and the winding of the phase that was already addressed by the online monitoring system. And the defect in this case was on the stress ring. This is the corona stress ring on the top of the winding. So you can see there is some burning trace that was generating the partial discharge, the hydrogen, and also a little bit of acetylene. Okay. Now, if you don't have the information that there is a partial discharge, in which winding and in which phase, you might end up to spend a lot of time doing this acoustic location. Okay, so to answer the question here, the best practice that we see and the main use of these sensors is in making an investigation and locating the source in a second stage. So when you already know that there is something. In that situation, they are extremely useful, especially if, like in this case, you use the bushing adapter as electrical trigger and the acoustic sensors for the triangulation triggered by this electrical additional sensor. So you don't use the all acoustic method, okay? So in this case, I would say the acoustic sensors really are helpful for transformers in order to pinpoint with reasonable accuracy the main source of issue in the transformer.
Excellent. So you had really 3 modes of measurement here that brought it round really. So you had the gas analysis initial, yeah, and then you did the acoustic and online PD monitoring as well. So
Correct.
all 3 mechanisms
Correct.
came back.
Correct.
Now, is there a portable monitoring solution that they could put on the transformers rather than doing the? So sometimes, you know, people don't want to go to the great deal of expense of doing every transformer. So are there portable units they can use?
Well, doing on every transformer is quite expensive procedure. So our suggestion is really to do this kind of process. So you can start with gas in some transformer, and you just use a simple gas monitor. Then the next step will be the permanent electric system, which is cost affordable and at least tells you if there is an issue or not and in which phase. And then with a portable unit, portable acoustic system, you go and make this. So the portable acoustic system in that case is absolutely a good choice, and to use when the permanent system tells you, basically raise a hand and say, come on, there's a problem here.
Come and have a look.
Yeah.
Excellent. And I mean, and it's an important thing. You know, it's an important structure to say that, you know, if you've there's that old saying, if you've only got a hammer in your toolbox, every problem looks like a nail. I say that all the time. So having multiple elements to an inspection, especially on a critical asset system like an electrical distribution system, you want to be using multiple condition monitoring.
Absolutely. It is a matter of combining the data in information. And find causation between the different elements. Correlation enough. Correlation itself is not enough.
Yeah,
You might have
agreed.
perfect correlation between things that don't have any causation.
Yeah,
So if you put together elements of different nature, like in this case, gas, electrical charge, and acoustic emission, that's the best way to determine the failure mode and understand what is the root cause of the problem, and then decide what is the best action.
yeah. Got a couple of questions come in, but I'm going to wait until ask the questions when we
Right.
after we finish going through this. Okay. So next, I'd like to Bob. This is your question, mate. Okay. What are some of the common mistakes that could be made in performing infrared inspections on a transformer?
Thanks, Martin. Well, as many of you have said, one piece of information isn't always the best way to look at something. So you may have a excellently trained technician that knows how to, use the camera properly, and the instrument's the proper instrument, as Roy was pointing out. But then when all of the information comes to the report writer or the diagnostic person, often it could happen that you don't have all the information that makes you use that information properly. And I'll give a few examples. On a transformer, very important to go with the infrared inspection would be the visual inspection of the transformer itself. So if you were to take a scan of a radiator, for instance, a very common target for an IR scan, along with the bushings, but if the radiator has an odd profile, one of the first conclusions you will possibly have is, hey, the level is low. So an important piece of information to go with the scan would be obviously the photo of the transformer, which normally is taken at the same time you get the image. But additionally, you would want to look at level gauge photos to make sure you snap a picture of that. You'd want to look at the temperature gauge on the transformer, because the level gauge is corresponding to the temperature of the fluid. As it heats up, it expands, of course, and the level has to be diagnosed in relation to the temperature. Another thing we like to have, which may sound a little strange, is the bottom oil temperature of the transformer. If the level is indeed low in the transformer, such that the radiator tube or the system of the forced oil is breached, you'll actually lose the effectiveness of the radiator, and it could be the level's low enough that your temperature gauge is actually out of the fluid. So it may be reading a temperature of, say, 40 centigrade, and at the bottom you see a temperature of 40 centigrade. Well, that's odd, because usually the top oil temperature is 10 to 15 degrees higher than the bottom oil temperature. So you can put that piece of information along with the level gauge, along with the temperature gauge, and then you can diagnose properly what that scan means. Along with that would come oil data. If the transformer is indeed overheating, you will see gases in the fluid that correspond to an overheated oil. Higher temperatures, we would not necessarily see acetylene, which would be an arcing condition.
Arcing issue,
yeah. But ethylene is a high temperature gassing, and all the gases start to grow as the temperatures go up in the transformer. So gauges, oil data, having the proper photographs of other things besides just the infrared scan. I've heard it mentioned emissivity, so depending on what component you're looking at, to correct, if you want to see an actual temperature versus a temperature differential, you'd want to make sure that you have your camera set properly for whatever surface you're looking at. I think that's about all I would want to bring up about, and they aren't always common mistakes, but we scan 5,000 transformers a year, and all these pieces of information go into our report writing, and it's just amazing to see how they fit together. So a scan alone isn't always, the best way to go about it without.
No, absolutely. I agree. And I don't know if you agree, Roy, but I mean, I always say focus, range, and distance. You get those, everything else we can play with.
Yeah.
You know, so if you give me an out of focus image, I can't do nothing with it. If the range is wrong, I can't do nothing with it. And if it's too far away, spot size ratio, I can't do nothing with it. So for me, I always say get those three right, and an experienced thermographer can typically help you out with the rest of it. Would you say that's a fair comment, Roy?
Yeah, I like that comment. And
Yeah.
I love Bob's discussion about supporting data. It's great, great idea. Yeah,
Yeah. And
absolutely.
you know what's been a common theme across all of these? The visual inspection.
Yep.
Yeah, the Mark 1 eyeball and the technician who knows what he's looking at. So don't worry about the technologies. The visual inspections first, because you can see something, you can smell something, you can hear something. And if all of those are telling you something's wrong, don't even worry about getting your camera out. You got more problems to worry about. Great. So, okay, we're going to jump into another poll question, okay, before we go into the general discussion. So, a follow on from the last question, which of the following condition monitoring technologies do you currently utilize? So again, we've got infrared, ultrasound, partial discharge, power analysis, and oil analysis. So we asked you which ones you were trained in, and now we're asking you which ones you actually physically utilize on your inspection. So we'll wait and see the results on that. And then, by the way, I've got some great questions coming in. I'm going to start getting around to the questions in the general discussion with the panelists. But just to let you know, if we don't get to your question, we will follow up with them in writing, and we will follow up back with you. So just sharing that with you. So hopefully we'll have the results of our poll. See if it's the same. So again, thermal imaging. So again, more people are using thermal imaging, but remember, less people were trained in thermal imaging and oil analysis. So that tells me there's a whole bunch of people out there. Comparing these to the training figures, I think we've got a lot of untrained users. Would you say that's a fair comment, guys? Who'd like to jump in on that one? Roy, you're the senior trainer. Would you like to say something about that? Those numbers, man?
Well, I think we always see the opportunity there for additional training too. Would be the piece of that usually jumps out at me. We may have handled level 1 training by definition, helping the user be able to comfortably use his camera. He knows how to operate it functionally. He knows how to do what you just mentioned of getting a good focus, making sure you're in the right range, trying to make sure you're within the measurement distance. But until you have experience and the years and then the additional training to support proper measurement, a very good friend of mine in the past has often referred to this as an imaging science rather than a measurement science.
Yeah.
And so that's that really comes out of this for me is a very important statement in turning around and saying, we can learn so much from the image, but all of us typically want to move very quickly to the measurement. We want a temperature, we want a number. It's really best as an imaging science. And the other, maybe we can do that, maybe we can add to that. So I think it's true of all the technologies is that many times the first class is not enough. There's additional training or follow-up training, because I will promise you, you could take the same class 6 months later or a year later and get a whole different perspective to it. And I'm not suggesting that, but you learn every time you hear it. I could go listen to Alan present ultrasound to me, and I could go watch him again in 6 months or a year. And because he said something slightly different or in a different way, I might learn it better, or I might better understand it. And plus I'll understand it better because I've been in the field, hopefully utilizing that technology between those gaps. And so experience is really where I think it comes down to in being provided the opportunity to understand what you've seen or what you've heard by additional training or by additional research or by visiting.
Let me throw a question at the panel. The first technology I learned when I left the military was vibration analysis with Rockwell Entech back in those days. And the first course we did was not a level 1 vibration. It was called IVT, Introduction to Vibration Technology. It was a 3-day course. That 3-day course was to introduce you to the analyzers, the science, the technology, the basic measurement techniques, primarily show you where you're going to screw up and to avoid those, and you did IVT, and then 6 months later you went did and done your level 1 vibration, but you were experienced with using the tools, and it actually made so much more sense to me when I went back on my level 1. I had all the right questions, all the right things. So what would you say, do you think there's a space in the industry for an interim user course before we start getting into the you know, the ASNT level 1s, level 2s, level 3s? Alan, I'm going to throw that one at you
Sure, but
first.
I mean, if you get me ranting about training, especially about certification training, I hold a bit of a unique or a different opinion about where certification fits in with everything, because everybody has it under the mind, I've got to go do this training so I can get a certificate to hang on my wall. And certification is great because it provides foundational knowledge, you know, the stuff that you need to know to understand the technology and to make sure that you can go out there and use it in a competent way. But you know, just as there's different levels of certification, you know, Cat 1, Cat 2, Cat 3, what have you, there has to be some user experience in there.
Yes.
I was just working on a paper with Jim Fitch at Noria a couple of weeks ago, where our theme of this paper is to talk about experienced ultrasound inspectors paying their knowledge forward. In other words, and where this all started with is, if you look at some of the adjectives that are used to describe ultrasound: versatile, user-friendly, it requires minimal training, you know, quick return on investment, you know, your first line of defense. There's this long list of things that paint this picture in your head that this technology can just be thrown into anybody's hands, and away they go, and they're going to get results. And usually that's what ends up happening. And we see that from the 2 poll questions that we just did, is that there's not that many people going out and getting certified in ultrasound, but there's lots of people going out and using it. And so, you know, to me, it's looking to those experienced ultrasound inspectors to mentor, to provide some kind of a leadership and play their knowledge forward if they're not going to go out and use the technology themselves. But then you have to look for training that goes beyond just certification. You have to look for training courses that that also offer some kind of an affirmative. Let's say they challenge your paradigm. They make you think differently than you may have thought before, so that you can not only just understand how the technology works, but how I can go and safely apply it to a specific application.
The mentorship programs within companies should be really encouraged, I would suggest.
Yeah.
Because we're going to lose all that tribal knowledge.
We've been investing a lot in that at SDT. We, as everybody else has done, we've pivoted our certification trainings online. But in that same process, we've also taken mentorship programs and put them online as well. So we're trying to find creative ways to move the experience forward, so that people aren't just learning the foundational stuff, but they're getting the practical and the affirmative information that they need to be competent. Yeah.
Excellent. No, good. Okay, listen, I've got more questions on this forum than we've ever had on any of the others, so I'm going to start winding through them. And as I say, guys, if we don't get to them now, we're going to obviously get to them after. The panelists will come back and answer these questions for you. So, first question, can or will the experts provide an estimate on time periods to conduct the combination of infrared acoustics and PD testing? And that's from Gabe Benani. So let's throw that one at Bob. How often do you suggest, so that they're asking about a time, how often should you do infrared ultrasound and PD testing?
At a minimum annually. And if you have a transformer or a component that you believe has suspect behavior, then you would step that up to perhaps even monthly. In some cases, you may be drawing a sample weekly, and then you decide to go to a monitor because of the cost and even the safety factor of being around the component.
Yeah, no, great. And I would probably hazard to say this is more driven by risk and criticality than a generic, time-based maintenance schedule. because you know you look at things like NFPA 70, IEEE, etc. They have recommended, but that doesn't give any level of consideration to criticality and risk. Yeah, Marco, would you like to chuck something in on that?
Yeah, correct. Especially for the partial discharges, there is no absolute no indication on criticality. And since you have mentioned the IEEE, and Roy was talking about experience and experience. This is what we need to give training. But in the poll, the partial discharge training was very poor.
Exactly, yeah. I think we would get different results if we conducted that poll in Europe and the Middle East.
Yeah, absolutely. Especially for the medium voltage assets, for switch gears. Definitely. Yeah. Poor training because there is poor knowledge and experience at the moment. But what I have seen as part, for example, of the IEEE working group for the acoustic measurements, a huge difference given by experience since 2007 from the previous edition. In these 10 years, the working group was full of experts, and in this new guideline, there are a lot of more case studies. It is important to show these case studies. There are nice cases on on cable boxes in transformers, in shell type transformers that you would imagine is very difficult to detect something in shell type transformers. So these cases are there. There is a lot of experience. Hopefully this will bring more training. This is absolutely what we need. And then doing PD inspection, I would say it depends. If the transformer is not equipped with any online monitoring system, I would agree on the infrared inspection annually. For the PD, it depends what you are looking for. If you are looking for, 1 picocoulomb PD, I would say give up. If you are looking for something big that you already know that there is something possibly there, yes, this is something that you have to do, but mainly on exception, not a regular base.
Yeah, and I tend to look at PD scanning more like power quality, that you want to run it for a few cycles. I mean, it's not like you can just do turn up, do a quick TEV inspection and you walk off and you come back next year. I mean, we've seen people, and please jump in if what I say is wrong, but I've been told that if you look at HV assets, up to 85% of the failures in HV assets start with some form of partial discharge.
Yeah.
And the nice thing about detecting PD is it's a really early form of detection. So it doesn't go from PD to an arc flash explosion. But if you're picking up the PD, depending on how severe it is, and you're picking it up early enough, you're really getting in front of it from a reliability standpoint. You're jumping up really up on the PF curve.
Absolutely.
So for me, it's super important. But I would, and again, am I wrong by saying that really a good partial discharge scan would be maybe to put a meter on it and let it run for 24 hours, 48 hours, and then see what you've got? Because I've seen results from partial discharge scans where the daily scans show nothing, then all of a sudden it's whoa,
Absolutely.
and then they come back the next day, there's nothing.
Absolutely.
So, and that tended to be driven by load and cycling in the plant, and not by when it was in a static condition.
Absolutely. It can be, if it is linked with the leakage fluxes, it is driven by the load. If it is in semiconductive layers by temperature, it can be there and after 30 minutes disappear. We have seen PD actually almost arcing activities for a few hours and then disappearing for months. And then again, and every time it was increasing the acetylene of 2-3 ppm. So it is not a single spot quick measurement that you can do.
Excellent. Got a question for you on your presentation from Gabe. He says, for your transmission discussion, did they insert the acoustic sensor inside the transformer tank?
No, they were outside.
On the outside,
yeah. It's very simple. I guess maybe Alan can talk more than I'm not an acoustic expert. We did something that was really simple. We just took off-the-shelf sensors, put some conductive gel, put on a tank, but we knew where to put it because we knew where the PD was, and then was a couple of hours work to see that was on the very top of the winding.
Absolutely.
So
Alan, do
easy.
you want to jump in on that?
Sure. Well, I mean, I would just echo what Marco said. The key to that whole statement was you knew where to put the sensor. If it was, I don't know what type of acoustic sensor you use, but if it was a higher frequency one, then it becomes even more important, the sensor placement, because as I said earlier, ultrasound's introverted. It doesn't like to party with other sounds.
Yeah.
It's going to stay where it's created. So.
Yeah.
Excellent. Alan, I've got a question for you from Lee McClish. Lee, obviously, we all know Lee. He's
Yeah,
a great
we know Lee.
guy here. Can you provide examples of results of using ultrasound detecting problems with 480 volt switchboards or transformers?
So lower voltage.
The lower voltage, I mean, and again, obviously it's all current driven, isn't it? I mean, higher available fault currents, and yeah. So examples of what we do that.
For sure. I mean, we're using airborne sensors, and now we're starting to see a permanent mounted sensors. So monitoring motor circuit controllers on a 24/7 basis. I mean, I can go over to the 110 volt light switch on my office wall here, and I can play around with it and create an arc that I could hear easily with an ultrasound detector from maybe 100 feet away. So
Yeah.
if there's arcing there, then it really doesn't, to me, it doesn't matter the voltage. The arcing is producing frequency, it's producing noise in all the different frequency ranges and even at very low voltages.
Exactly. I mean, MCC buckets, for instance, from an ultrasound standpoint, or from an infrared standpoint, can be an absolute pain in the backside, to be very frank. But ultrasound scans of MCC buckets, etc. And again, we're not listening for corona because that's typically, I think, 4160, 4.5 kV and above. Would that be a reasonable?
That's right.
Marco? 4160.
That's right.
But arcing and tracking, definitely you'll get it in all voltages, and I always encourage the use of ultrasound on motor control centers, because from thermal imaging there's very little we can see.
And the key for those, Martin, is all you need is an air gap. So
yeah, exactly.
And the air gap could be anywhere around the outsides of the panel. They could be vented, so you can pick it up right through the vent. As long as you have that air gap, you can find it airborne. And if you don't have that air gap, then we do see more and more of them installed with these ultrasound ports that actually allow you an air gap right through a port. But you can even just take an ultrasonic contact sensor with a magnet and put the magnet right on the panel. If there's anything going on there, that will resonate through the steel.
Yeah, and depending on the severity, obviously. I mean, because it's
for sure.
Yeah, like you say, oil. I love contact inspections on transformers, especially for tap offs and like the wonderful piece of equipment for that. Fantastic. Good question just come in. It's a very poignant question at the moment. With all the weather-related issues with the electrical grid in Texas this week, can any analysis be used to identify likely weak points in the distribution system that could be addressed in advance? So, Bob, you've been quiet. I'm going to throw that at you.
Whoa, I got to think about that one.
Yeah. I mean, I think a lot of the inspections we're doing.
Send some Canadian power utilities guys down there, because ours seem to run all year long.
That's well, I suppose it's about design. I mean, exactly. It's you go to the oil fields in Calgary, mate. I mean, there's not a problem with transformers out there, but they've designed and run them and managed them and managed the asset to the condition.
Yeah, the temperatures are going to be way different when the ambients are super cold and the loads are low. So there's some things that are going. Moisture is a great example of that. Moisture is going to just run right into the insulation when the fluid's cold. It could be weather related, could be load related, but you don't want to necessarily measure, parts per million as you want to measure percent saturation. That'll give you an indicator even in the colder temperatures.
So I think if you were utilizing, so obviously got a few questions on cable PD, because that's another big area of it's not understood of what you can do with the equipment, how great it is for actually pinpointing literally within centimeters where the PD issues occurring, depending on the equipment you're using. But if you're utilizing all of the technologies we're talking about, writing down your protocols, so for instance, where you're going to take the measurements, how you're going to take the measurements, the skill level required to take the measurements, any anomalies we're going to pick up, either in the gassing or the temperature or the acoustics, all of those are a great indicator, because if you've got stresses when it's not being stressed, you know what I mean, if you've got indicators of failure when it's not being stressed, then when you start stressing that stuff, you know, like temperature, and I always get to think, well, switch it off and catch it as it's cooling down. We go, well, it's T to the 4th power, mate. It's not a nice linear decay. You switch off the heat, it goes cold very, very quickly. So, you know, so I'm always like monitoring, managing the data. When you come up with something like this, you'll pick up the bad actors within your distribution system and where you should spend some time. You know, if you've got budget, don't fix anything that don't need fixing. Just fix the stuff that you found issues on. But Alan, you're right, mate. I mean, it's like you go up to the northern wilds of Canada and you've got transformers out in the middle of God knows what. But it's not an easy question to answer, really, is it? I think just having a standard way of doing things. But listen, I know there's a great deal of questions that we're not getting back to, but the panelists will all get these questions, and they will all respond to them with their take on that. But so I'd just like to sort of start winding things up, guys. Thank you very much for taking the time out of your busy day to share some of your expertise with us. We're going to do something different, EPRA, in the next 3 forums, and I'll probably grab some of you guys back for these. No, I will grab all of you guys back for one of these. But we're going to do a series of 3 forums on a set of, you know, a particular problem that we're seeing. So the next 3 forums, we're going to discuss the theory behind aspects of electrical power reliability, and more importantly, the better practices. And I use the term better practice. I will say best practice is yesterday. Yeah, we still strive to be better. So in EPRA, that's what we say. It's like not best practice, it's better practice. We're always trying to do things and look along the way on there. But great forum, guys. Really thank you for your time. Final thoughts before we go, anyone? So Alan, 1 minute, final thoughts.
You know, for me, it's still all about safety. I'll go back. If we're going to talk about training, if we're going to talk about putting these equipment into, let's say, lower skilled or junior technicians, gosh sakes, just make sure that these guys are trained on safety. They're working around assets that can kill them.
Excellent, totally agree. And that's, for me, ultrasound is one of the key monitoring technologies for electrical safety. If you're going to open a panel, you better scan it first. Yeah, before you put you in there. Roy.
Yeah, well, and along those lines of some of the things that I probably say I will have avoided was based on using other senses. And so we talked about using the visual images to use your nose. You know, Martin, you referred to it earlier. I've smelled ozone before. I didn't need the ultrasound. I knew I wasn't opening that panel, that type of thing. So just from the standpoint, I thought some great stuff. As I mentioned earlier when we did the introductions, as always, I learned something from everybody on the panel. Thank you, guys.
Thanks. Marco, again, thanks for jumping in all the way from Italy. 30 seconds.
Well, I want to, of course, say thanks. This is always really nice and very good chance for me to talk about this. I said this last forum, I said again, this applied witchcraft, which is partial discharges. give a chance to the partial discharges. Trust it, it works. So very great opportunity for me to talk about this.
And we're going to do our best in EPRA to make people aware of these technologies. I suppose as an organisation, that really should be our key goal, is to really introduce these technologies and their benefits to the membership. Bob, get the final say.
Oh, I'd like to echo Alan with the safety aspects. We have a saying here, work safe, home safe. And these activities are done energized. And so even a high percentage of transformers, cabinet transformers, You have to often have ways to do this safely with Windows, and then just make sure that people are trained in the electrical aspects when you're in the electrical areas with arc flash and you know, shock hazards and so forth. It's
Absolutely.
number one.
Thanks, Bob. And then finally, this is the only pitch you're ever going to get from me: membership for EPRA. I mean, you know, EPRA is an organisation that's driven by its membership. You know, and again, as a member, we expect you within EPRA to actually participate because it's about sharing. And I think everybody on this forum has shared their experiences, and we've shared with one another. And we need a membership. You know, so if you know, just join. The membership is free. You know, it's not like you're paying for this, but we, you know, this organisation will grow with shared expertise, and we will all benefit from that. So again, sign up for the next series of forums. If you sign up for one, you're registered for all three. But thank you very much for taking the time to attend. Thank you for the panelists for sharing again. And listen, everyone stay safe, and we look forward to speaking to you soon. Thank you.
Thank you.